Good morning, everyone. Myself R. Rajavardhan Reddy from CSC E section, currently pursuing my BTech studies at Srinivas Ramanujan Institute of Technology. Today, I am here to give a presentation about the topic divergence in vector calculus. The subtitle is An Introduction to its Concept and Applications. Let us see the introduction. The divergence is a scalar measure of the rate at which a vector field spreads out from a point. It quantifies the net flow of a vector field in or out of the given region, typically used in physics, especially in electromagnetism and fluid dynamics. Let us see its mathematical definition. For a 3D vector field function f is equals to f1, f2, f3, then divergence of f, which is also represented as del dot f, is equals to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, where divergence of del dot f is the divergence operator and function f is equals to f1, f2, f3 is the vector field in 3D space. Interpretation in divergence. There are three types of divergence: positive divergence, negative divergence, and zero divergence. Let us see what is meant by positive divergence. The positive divergence means the field is spreading out from a point or source. Negative divergence, which means the field is converging towards a point, which is also called as sinking. Zero divergence, the field has no net source or sink, it is incompressible. Example, steady flow in fluid dynamics. Divergence in 2D. For a 2D vector field f is equals to f1, f2, the divergence is divergence of f is equals to dou f1 by dou x plus dou f2 by dou y, which is used to analyze 2D fluid flows and electromagnetic fields. Geometric visualization. The divergence of a vector field can be visualized by looking at the flow of vectors at a given point. There are three types: positive divergence, negative divergence, and zero divergence. For positive divergence, vector points outward like water flowing from a sprout. Negative divergence, vectors point inward like water being sucked into a drain. Zero divergence, vectors circulate or stay constant in a magnitude and direction. Applications of divergence. The examples for the applications of divergence are electromagnetism, fluid dynamics, gravitational fields, and engineering. In electromagnetism, it is used for Gauss law for electric fields. In fluid dynamics, it describes the compressibility and behavior of fluids. In gravitational fields, it describes the distribution of mass. In engineering, it is used in analyzing material flow and stress fields. Here is one of the example. Show that del square of f of r is equals to f double dash of r plus 2 by r into f dash of r. We need to prove the LHS is equals to RHS. Let us see LHS. Del square of f of r. Del square means dou square by dou x square plus dou square by dou y square plus dou square by dou z square whole of f of r. We can write this as sigma dou square by dou x square into f of r. Dou square by dou x square means double derivative. Sigma we can write it as sigma dou by dou x into f dash of r into dou r by dou x. As we all know, dou r by dou x is equals to x by r. Substitute that in this equation. After substituting, again differentiate with respect to x by using u by v rule, where differentiation of u by v is equals to u dv minus v du minus u dv by v square. By applying this formula, we will get f double dash of r is equals sigma of x square f double dash by r square plus sigma of f dash of r by r minus sigma of x square f dash of r by r cube. As we all know, sigma of x square is equals to r square. By substituting that in the given equation, we will get the RHS part, which is f double dash of r plus 2 by r into f dash of r. Hence, it is proved LHS is equals to RHS. Conclusion. Divergence is an important concept in vector calculus with numerous applications in physics and engineering. It helps quantify the spreading of a field, whether it's a fluid flow, electromagnetic fields, or gravitational fields. Understanding the divergence is essential for solving complex problems in fields like electromagnetism, fluid dynamics, and more. Thank you for giving this wonderful opportunity.